Well, Ben, I'm looking forward to hearing from you. I'm going to read off your introduction and then hand it off to you. Ben Graymig, Ph.D., is currently a research agricultural economist in the Conservation and Environment branch of the Economic Research Service in the United States Department of Agriculture. He's an agricultural economist working predominantly on applied research at the interface between agricultural production, public policy, and the environment. Ben, thanks for being here.
Thank you. Good to be here. I want to make sure I clarify that I'm in the process of a transition from ERS, which is where I am working still today. Not today, actually, this particular date. I happen to be on leave today, and importantly, as I'm presenting this, you'll see at the bottom of this title slide here the usual disclaimer for federal employees. That is that I'm speaking for myself, and I'm presenting this information as Professor Ben, soon to be or incoming Professor Ben at Cornell. And I'm going to talk about a recent report that we published just here in the past year. The screenshot here in the bottom right is a copy of that cover of that report, and there'll be a link at the end. We can share it. You can easily find it online. But basically, what this report does is it tries to go in and get together as much data as possible from as many different sources as possible to really assess sort of where we are in terms of a variety of different soil health practices. And again, soil health practices are many. There's lots of different things that can be done on a farm operation, and they're going to depend on individual circumstance. I'm going to focus on, again, findings and information and data that are within this report, and hopefully pull out things that are of interest to a broader group and can point you to some key evidence or circumstances that might be helpful for yourself. So we look at adoption. I try to update people here on exactly where adoption stands on some of these practices, but also importantly, sort of looking at what's going on in terms of potential disadoption or actual disadoption that seems to be happening. People who start a practice and then don't continue to use it. So I'll talk through a lot of those things, and I'm going to do it always really through a very economic lens rather than a purely agronomic one or a biophysical one. So keep that in mind. Happy to take questions and talk through kind of as we go. But there's a quick overview of what's going on. What do I think you can learn from what's in this report that I was a part of that you may not necessarily think would be in a government report or something from the Economic Research Service? There's lots of questions, certainly, that a landowner or a tenant or somebody else might ask you, depending on where you are in the advising and management of different types of farmland, about cover crops in particular. Obviously, that's a very popular practice that has been looked at a lot and is growing over time. People might want to look at cost projections for expanding or going into no-till all the way if they're already doing some form of reduced tillage, something like that that's out there. They might ask you about, just what is this worth, or what is it going to cost me, or what do I have to worry about if I try this new soil health practice that everybody's talking about, or that I notice some of my neighbors are doing. Why did somebody stop doing this practice? So I'm going to try and talk through some of those kinds of things as well. And importantly, this is all based on two key data sources. One is the Census of Agriculture that everybody's probably familiar with. The other is what's called the ARMS survey, the Agricultural Resource Management Survey, which is a much more detailed, in-depth farm and field level, depending on exactly which part of the survey we're looking at, survey that gives us some very detailed and rich information that we try to use to get close as possible to some sort of a causal estimate of the effects of these different practices on costs as well as production. And we focus on yield as the main thing that's there. I can't talk about everything that's in the report. It's hopefully a teaser to get you to dig a little deeper, especially if you want to look at individual studies and information, maybe something in the particular location of the country or soil or climatic type that you're operating within. There's good here, there's bad here, there's some sort of ugly. This is just sort of the nature of business and farming and agriculture, and also evaluating new things. So I'm going to dive in here on the economics. We can't talk about every practice. The ones that are covered in this report include tillage, so a distinction between no-till, strip-till, reduced tillage, mulch till or mulching. Um, is here. These are just sort of quick definitions to give you a sense of what we're talking about. When I talk about cover crops today, I'm talking about or focused on growing a crop that's in place with a primary conservation focus. That is, it's there in order to protect soil or try and keep nutrients in place over winter in between harvest and planting in the next spring. We'll talk about conservation crop rotations just a little bit in terms of the data, and nutrient management is really sort of more or less the 4 R's that I think we're all probably familiar with in terms of rate, form, placement, timing, those kinds of things. And all of this is guided by sort of the underlying soil health principles that NRCS uses. That is maximizing living roots or living plants on the field, minimizing disturbance, maximizing soil cover, and also trying to increase or maximize biodiversity. I'm not focused on those particular outcomes. I won't talk about those today. I'll talk about those economic ones, as I mentioned before. So, um, first and foremost, um, sort of if trying to evaluate adoption, people saying, should we do this? Shouldn't we do this? That kind of thing. The answer isn't always yes in terms of trying to evaluate these. That's no surprise to the audience here, but sometimes can be depending on what audience we're talking with. What we expect economically is that if the practice pays for itself, and that might be out over time. So thinking about a net present value of adopting that practice, if those benefits essentially exceed those costs over time, once we take into account discount rates and other things that we use to evaluate the opportunity cost of investing our dollars and our time into a new practice, if it pays for itself, then it has a sort of a pure economic benefit. But there's three main reasons that this might not happen, and they're particularly relevant when we think about these practices. One is timing. That is, when is the sequencing of benefits and costs? Costs oftentimes, right, are sort of front loaded up front, and they're also very certain. That is, we can probably estimate exactly what it's going to cost based on materials, based on labor, equipment, land costs, all of those things, what something is going to cost up front. It can be a lot more uncertain exactly what or how large the benefits might be and how long it might take to experience or realize those benefits. That mismatch between those costs and those benefits is a real obstacle, right? And it's not just for individual decision makers or for farmers. It's a societal challenge too when we talk about problems like climate change and those kinds of things that have big upfront costs to sort of change the systems that we're working within. Who exactly captures the benefit or bears the cost is also really, really important in this context. Obviously, with a farm level practice or management practice, a conservation or soil health practice, a very meaningful share of the benefits may not necessarily accrue directly to that farmer, right? They may be societal benefits in terms of a water quality downstream benefit or in terms of carbon sequestration in soils, depending on exactly what practices you're talking about. So if there's benefit accrual beyond the farm gate, that's great for society. But if all of the costs are borne solely by the operator or the landowner, depending on different tenancy arrangements, then that could be a challenge or an obstacle to getting that practice put in place if there aren't enough private benefits as well. So synchronizing those things or evaluating who's bearing the cost and who's getting the benefit is important. The other is just difficulty of knowing exactly what's going to happen. Part of that is uncertainty, but I'm going to focus here on the idea that where you're located, what your agroclimatic conditions are, where you're operating, the crop that you're growing, the rotation that it operates within, all of these things, your overall production system can drastically change whether or not adopting a practice or a group of practices is going to be attractive for an individual operation, and it makes it challenging to forecast exactly what's going to happen in terms of an outcome if you're evaluating a new practice like this. Um, this issue of who gets the benefits and who bears the costs is the division between what I described as private benefits that accrue to that farmer or that landowner versus things that might be beneficial or exert costs on the public is really important and creates a big tension here depending on the circumstance and particular issue that's going on. I'm not going to go into the details. This is to sort of a fire hose of information to sort of give you a preview into sort of what's here and all the different rich detail. The take-home message here, and you'll see take-home messages throughout the slide deck, tries to summarize a lot of the information that's at the top, and then I might not have time to go into as I'm going through all of these slides today. Basically, right, whenever there's a negative private return, but there is a positive public return, this is the situation in which we have traditionally provided public support through USDA programs, through State Department of Agriculture programs, through NGOs and other more local organizations, maybe through local conservation districts. But this is when we oftentimes use public incentive payments, publicly provided incentive payments to try and induce adoption or to just get people to trial a practice, right? Just because someone doesn't adopt a particular practice, even though it has lots of great benefits that we extol, right? It's certainly not the case that the producer is acting irrationally. In fact, they're probably acting in the most rational way possible, even if they're waiting to decide exactly what to do over the longer term. So this alignment of public and private benefits everything has to line up in order for this to really work. Next, the trade-offs that are involved are real, right? Not all practices are uniformly good. They're not going to be good at every point in time or every place across the landscape for every individual farmer, and there's always going to be costs, right? There's no free lunch, as economists like to say, right? So there are lots of external benefits in terms of water quality, possibly in terms of greenhouse gases and other things that we hear talked about a lot with respect to a lot of soil health practices, some of the ones we're going to be talking about today. But there are always costs associated with it, and it may be the interaction of soils and climate and other things, or you may have a follow-on impact about having to do with compaction or something like that. So there is no automatic environmental win. I definitely want to emphasize that, even though there are lots of opportunities for environmental improvements. And when we're talking about these different practices, we really need to focus on, when working with an individual landowner or farmer, a rancher, what resource concern are they trying to address, right? And is the practice or practices that they're considering going to solve that or going to address it, especially in light of all the other things that are going on in that operation? The behavioral choices and the decisions that people make aren't just about the dollars and cents. There are lots of other things. I just sort of put this in here to highlight that there are lots of other factors that are not purely economic that are important factors and do influence what goes on. I'm not going to talk about all these other things that you see on here, but they're all potentially important, and every decision maker
just get to what you are going to do.
Every decision maker is going to experience different pulls and pushes in terms of what's driving them to make the decisions that they're making. Now, there's money on the table, right, in terms of trying to evaluate these practices, and that's why lots of people have been interested in soil health. The core underlying or big picture logic behind public assistance that I mentioned for some of these practices is that there's public benefits, right? It's not just a benefit to the farmer. There are benefits that society gets from that. There's two main ways that we get assistance for these practices and to put them in place, either technical assistance. So that's working maybe directly with NRCS, but it could also mean working with a technical service provider that's been certified by NRCS to provide conservation technical assistance. Financial assistance is the other way. There's shorter term assistance for maybe 1 to 3, potentially up to 4 or 5 years, if you can get into the Conservation Stewardship Program, or CSP. EQIP is generally shorter contracts, but these can help farmers to trial, of course, these practices, offset their initial cost. Maybe when learning is the hardest and you got to figure out how to deal with some things the first time you try these practices out. Longer term financial assistance may make sense. Thinking about this as an economist, whenever that private benefit maybe remains negative or is very low relative to some large public benefit. People may be familiar with the pandemic cover crop program, and then several states that have since adopted similar programs that provide discounts on crop insurance for adopting these kinds of things. So there are a number of different public assistance programs out there. Some states have invested heavily. Maryland comes to mind in incentivizing cover crops as well. The instrument, the vehicle that we use to try to incentivize these programs really needs to fit a specific situation. And if a 1-year cost share is being offered, or financial assistance payment is being offered for a practice that has negative long-run private returns, then we can't expect people to adopt practices, farmers, ranchers, any longer than that financial assistance is available. So it's a 1-year program. We wouldn't expect people to necessarily keep doing that practice on into the future. So we got to be able to try and evaluate the situations where it does or it can pay for itself into the future. Quickly, I'm going to try to, as quickly as possible, talk about some of the current practices, how much they're adopted and where they're being adopted. Again, this is to try and just point you to some data, but the two key sources of information that I'm using here are the Census of Agriculture, only every 5 years, and the ARMS survey I mentioned earlier. Both are collected by USDA, both by NASS. ARMS is collected in cooperation with the Economic Research Service. If you're not familiar with it, the main difference in the data I'm going to present today are that you have operational level data. So at the whole farm or ranch level, we get information about the adoption of the practices that we're going to talk about. It doesn't have very much economic information about costs paid or prices received. That's more the focus of the ARMS survey that I'm going to talk about. The disadvantage of both of these really is that they aren't constructed as a panel or a longitudinal piece of data where you get an observation about every farm at each point in time. You can sort of construct some of these panels, but what that means here is that when I talk about percentage of acres that are present, that are in no-till or cover crops or some other practice in a given survey year, it's not telling you the amount of continuous adoption of that practice, but rather how many acres or what share of those acres are in that practice in a given time. We can examine up to 4 years of continuous practice adoption in ARMS as a sort of caveat. Let me dive into the data here. If we look at the tillage practices that I mentioned and the cover crops and conservation crop rotation, this just shows for the most recent year that data are available, what those adoption rates are, or rather the percentage of acreage that is represented of each of these individual commodities by these different practices. We'll talk about sort of trends here in a minute, but basically you've got a range of values depending on crops, from 19 to 20% up to as high as 59% here in terms of no-till specifically. Conservation tillage, inclusive of no-till and reduced till, gets you higher, up to as much as 80% of an individual crop, and closer to half on the lower end for any of these. Cover crop adoption is lower overall. Of course, it's a practice that hasn't been popular nearly as long as conservation tillage or no-till has been, but there has been an upward trend in the overall adoption rate, which I'll try to unpack a little bit more as we go along. And then you can look at combinations of the practices, sort of cover crops in combination with different tillage by crops. So there's a lot of data to look at and dig through. I'm not as interested in trying to talk about trends really as I am in trying to get to the economics. Conservation tillage has increased. Maybe it's slowed a little bit, and maybe there's been a pickup in the last most recent year of these data. If you look at the rightmost bar in each of those groupings for the most recent year, no-till seems to continue to have sort of taken a jump here at the end of that time period, partially probably from a reduction in the reduced tillage acres, but you've got a slight increase anyway. We're at a third to 40% of acres, 38% of acres for these different tillage practices across the different crops. Of course, it depends what crop you're looking at. But this is largely sort of leveled off, it looks like, for cotton, and maybe been a little bit more variable in terms of soybeans when we look across crops. Why might try to probably find some explanations. Why might no-till have stalled out in terms of soybean adoption? Obviously, we have high rates of herbicide tolerant crop varieties that we're using. And the concerns and issues associated with herbicide resistance and weeds have potentially been a factor here. When you project no-till cost savings, it's really important to consider what's going on in terms of weed control or the weed spectrum that the producer or the landowner has in place before trying to just think about what cost savings, for instance, might be achieved through adoption of no-till or just reducing the tillage intensity. Resistance, weed resistance, or rather herbicide resistance, chemical resistance in particular, is really the key mechanism that could convert what may look on paper like they're going to be cost savings, but actually result in a cost increase depending on a particular producer's situation or field that you're operating in as you evaluate some of these kinds of things. Switching to cover crops quickly, rates have been increasing overall, as I mentioned before. This is a little stretched out, this picture, but what you would see here is that silage, corn silage, is the thing that has had the crop that has had the highest overall usage rate in the data, at least the ARMS data from ERS. This seems entirely plausible. When we start to think about this, the economics of cover crops certainly favor the ability to graze or utilize those cover crops as a source of feed or forage for livestock operations. There is an entire report actually from a few years ago, the Bowman et al. You see there, 2022, on this. So if that's something that you're interested in, it really does a deep dive into looking at grazing and cover crops and how the economics are really, depending on where you are, but are quite favorable if you can take advantage of those cover crops, not just for soil health, but as a feed source for animals. Some of the other crops have probably have lower rates here, but there has been a continuous overall increase, and this has continued post 2023, as far as we can tell from the data that we have. I'll try to unpack this a little bit further here in this next slide. While we've seen increases in not just the popularity of these practices, this chart's a little jarring. It's not how you're used to seeing information, but if we look at a color band individually, so look at that, I don't know, brown or red, whatever it looks like to you on your end, that first sort of grouping of 3.4% of operations. What this is showing is that across census years, 12, 17, and 2022, 3.4% of operations reported cover crops in all of those years. We have had an overall increase over time in the percentage of operations that are reporting usage of crops and also the acreage basis of those adoptions. But what we see when we dig into this, and this is a new insight, I don't think this has really been out there very much. And this is because we can look in at the micro data and look at individual operations and track them over time rather than just sort of aggregated county or state or regional statistics. What we see is that only about 2.5% of operations that had cover crops in 2012 also had them in 2017, but then the same 2.5% did not report any in 2022. Similarly, if you look at 2017 and 2022, you've got about 2.9%. And then you see these blue chunks kind of out to the far right that show you the percentage of operations in each of those census years that were the only year that that operation reported any cover crops in place. And really, this starts to get at this question about how or why individual adoption may not persist over time. So there's some more sort of detail here, but basically the overall takeaway here is that over half of operations that report having adopted cover crops in a given year have stopped, or at least report no additional, no cover crops in a succeeding census year, which is relatively, seems like a large share, at least of the whole. This is a small share of overall operations, but something we're tracking. It's important, and there's a lot of questions about why adoption might not persist. This says, do we know why persistence appears to be low? The data don't tell us a lot of things about specific circumstances, but discontinuation is not the reason for discontinuation is not directly observed in these data. Certainly, there are some explanations. Could be that people are transitioning out of cost share programs that are intended to be relatively short-lived. It could be that they change the cropping systems or their management systems that they're using, and so these practices no longer fit into their production system. There is one explanation that we think we can rule out entirely from these data. That is that crop rotation alone does not seem to explain what we're seeing. In terms of this change from sort of one year to the next, one census year to the next in the data that are there. So the take-home message, if a practice on your managed ground is program funded through CSP, through EQIP, through maybe another program like in the past, the pandemic cover crop program, it's unreasonable for us to expect that practice to necessarily continue beyond the end of that contract, right? Unless you can actually identify some private return that outlives those program payments. And it might not necessarily be a pure economic cost. There are those behavioral considerations that I mentioned at the onset that are also potentially important, right? There may be a great synergy with some other use of your land, or there may be a conservation motive that is right up there with cost, and if you can break even on something, and it's something that an operator wants to continue to do because they've got the time or the energy or the equipment that's necessary to be able to do it. But this is an important thing to keep in mind as explanations for trying to understand and unpack why this persistence may be relatively low. This is really just sort of a tip of the iceberg, alerting us to this sort of circumstance. People have probably heard horror stories about cover crops and also heard great stories about people that have had good experience. We don't know and can't tell directly from the data, the census data, exactly what might be driving that. There are differences as we zoom out and look across regions. So the regional map here, the regions that ERS has defined, which are maybe a little weird or unusual if you're not used to seeing these this way, but the northern crescent is that pink looking area along the top sort of northern tier of states, includes the Great Lakes states. This is where we see the highest share of cover cropping in all the years in our data, and also a stable share. So there seems to be more stable levels of adoption across that tier, about 7.1% of operations in the heartland, or the sort of the Corn Belt, the greater Corn Belt. There is increasing adoption, and persistence does seem to be increasing as we look deeper into those data. The eastern uplands areas, which tends to be Appalachia, the Ozarks, has experienced some declining adoption as well as persistence. But you can dig into detail and look at other regions and areas in the appendices to the report if there's another area that's of interest to you. When we look at conservation tillage and cover crops together, joint adoption of them together, there does appear to be an increase in joint adoption. So cover crops and no-till together on the same operation being reported. Exceptions to that are in the southern seaboard and the eastern uplands. This might be a more meaningful metric only because these systems are being used together. Therefore, the private as well as potentially some of the external sort of public benefits may be more sort of secure or realized over time. All right, I'm going to switch gears here and start talking and talk about nutrient management. Um, the plot you see on the left, which looks really boring, these flat lines or curves, basically just shows us that at least in the ARMS data that we're working with here from ERS, there's really flat uh, flat estimates of the total application rate. So this is nitrogen pounds per acre. We also have, I think, plots for phosphorus in the report if you're interested. There doesn't seem to be any clear, upward or downward trend. But when you consider the fact that yields have increased over the time span we have here, the last 25 years, basically, then the implication is that nitrogen use efficiency has increased over time if our rates are indeed remaining relatively flat, like you see here in terms of pounds per acre. You can break that down and look at different shares of these different rates and changes for different crops depending on the crops that you're interested in. But the focus on 4R nutrient management, right, placement, time, form, all of those things has certainly become a big focus over the same sort of period, and perhaps has helped contribute to the improved nitrogen use efficiency as we've achieved higher yields over time. Digging a little bit deeper, trying to look at, again, intersections between practices. If we look at the cover croppers in our data, and then we look at their timing of their application, that's what we're looking at here. So you can see cover cropped and not cover cropped in the plot. The stacked bars sum up to the total amount of nitrogen being applied by each of these operations. And the key differences between the 3 bars on the left and the 3 bars to the right of this plot, the cover croppers being on the right, is a higher share of nitrogen being applied at or after planting. So in a post-plant period, the yellow or goldenrod or whatever that looks like to you, plus the light green color, those shares of the overall amount of nitrogen being applied are quite a bit higher. Candidate explanations for exactly what's going on here is certainly that it could just be that producers change their nutrient management when they adopt cover crops. That's an obvious explanation, but there may also be a genuine difference in the timing of those nutrient needs in those cover crop fields. The other is that the people who are adopting cover crops the most are the kind of managers that also adopt more management intensive nutrient systems. And I'm using management intensive to think about post planting in particular. Right, it requires additional information, planning, equipment, and other things to be able to do more of that post planting nutrient application, and arguably probably some more challenging logistics in terms of trying to squeeze those post-plant applications in on your system. What is profitability? What does the literature tell us about profitability? There's sort of 5 main things. I'm not going to go into too much detail on this. There's lots of studies pointed to here throughout, like I said, that could give you some more reading. But the main themes are about reduction in tillage intensity can reduce input costs. Net profitability, though, is quite different depending on what your experience is in terms of any yield effects, as we'll talk about in a minute. There's often a negative short-run benefit, economic benefit, or associated with adopting cover crops in terms of their costs, because there is a cost to putting that system in place. So at least over the short run, it may be difficult to get the economics to look favorable on paper. There's very much a dynamic process at work in terms of soil changing, the soil health from adopting these kinds of practices. So economic outcomes might be expected to be longer, realized over the longer term. In terms of risk and uncertainty, these are both affected by adopting any new practice. Certainly cover crops falls into that. And then the other is that, and very importantly, that the whole management system, the system of practices in place and crops in rotation, and whether or not you have livestock on an operation, really is important for trying to figure out what the overall profitability, not just economic cost, is going to be of adopting any of these practices. This is not a comprehensive, all-encompassing review, but it looks specifically at trying just to summarize studies in the economics literature that have looked at profitability explicitly. In terms of no-till, savings do appear to be real in the sense that there are cost savings, right? This is probably not surprising if you reduce the amount of time spent in the field and machinery usage and energy. All of those things result in lower out-of-pocket costs. There are some complications when we start to think about this, or that present themselves in different situations. One being that residue cover, having more residue cover in place from eliminating tillage can have different effects on pests and disease in different places. It can alter your soil structure, of course, over time. Some studies do find yield decreases. It's not all just, puppies and rainbows, if you will, in terms of what the literature tells us. And that's certainly based on where studies are conducted and soils and other things that are in place. Where no-till was found to be more profitable, this was primarily a result of input cost savings, not gains in yield or increases in yield. So it was about cost savings more so than increasing the revenue side of the balance sheet, I guess, on the farm level. Where it was less profitable, typically you had a situation where the higher chemical costs associated with weed and pest control offset those labor, machinery, and fuel cost reductions that are possible. In irrigated systems, it may actually be possible to get some more of those yield benefits that I said don't typically drive the profitability, the more profitable findings from some of the studies that are out there. I'm not going to spend any time here. There is a list showing lots of different studies and exactly what's going on, but I'm gonna keep moving here in the interest of time and leave these here as resources for you to look back on individual studies. Reduced tillage as opposed to no-till, a similar sort of set of differing results in different places. When considering reduced till versus no-till, if that's a decision that you're trying to evaluate or advise somebody on, as they're thinking about trade-offs, reduced tillage is probably I'll call it a lower variance option. That is, if your client is more concerned about downside risk rather than expected value, that's the thing that you obviously want to focus on to serve them best, not necessarily the mean or the average outcome. And the smaller change that happens with reducing tillage rather than eliminating it entirely is that incremental sort of change is going to be probably more tolerable to folks that have that kind of orientation in terms of what they're focused on and thinking about. When we look at cover crops, similar sort of set of summary results here for different findings in different places. As I already said before, the short-run return is often negative in the first 1, 2, 3 years. Lots of research has shown that in different locations, which is summarized in this table. Focusing in here on the yields, some studies have found that there can be have shown persistent sort of yield losses initially. There's a Midwest-based study as the first one that's cited. There's more mixed evidence when we start to look at experimental studies. The 4 things you see here are really important for trying to evaluate when do we see there seems to be consistent benefits, economic benefits When can these cover crops pay? One, I already mentioned, when you can graze or you can harvest those cover crops for forage. This seems to be the single most consistent thing that flips those economics and make it immediately have a benefit in the short term, an economic benefit. If there are cost share incentive payments, we talked about that. Obviously, that can improve or negate any short-term costs. If there is a important in-field resource concern that's being addressed, then that's also another big factor to think about for the individual farmer situation or a particular field within their operation. The other relevant today, certainly, if fertilizer costs are high or there is excess nutrients available at the end of the season, you want to try and keep those in place in the field, sequester them. This is another situation where cover crops will most often pay for themselves. So just asking, do they pay for themselves or not is really not an answerable question. We've got to think about the operational characteristics, whether or not they have livestock, whether you've got a weed situation you need to deal with in terms of weed resistance, and whether or not cost share might be available. Risk, loss, and ambiguity are all very different sort of things as we're thinking about adopting new practices and trying to understand different types of uncertainty. As you all know, producers tend to be risk averse. Most of us are pretty risk averse in our daily lives. There is no real consensus in the literature about whether or not cover cropping raises or lowers the net risk. Few studies actually evaluate this, though. That's really important. One of the things that comes out of this report and looking at the literature tells us that most of the risk that's being evaluated when risk is addressed directly is about perceived risk, which may be more important if that's really what's going to ultimately drive the decision to adopt or not. But it is something important to keep in mind. Loss aversion certainly drives a lot of decision making that goes on, and many producers will want to avoid any potential for large or frequent dips that don't smooth out their income, especially when the upside is, or even rather when there's a large upside to this, with those downside shocks potentially present. Trialing these new practices on individual fields or someplace where fixed costs are low is a common strategy to try to use to evaluate new practices, and certainly region or soil specific performance of an individual practice in your location would be a good idea to try to look at those kinds of things if you're trying to evaluate a particular circumstance in terms of the economics and the likelihood of getting benefits or resulting in costs as a result of that. The entire system is important. I mentioned this before. This is another key theme here. It's not just about that individual practice. So we don't just need to think about it by itself, but think about the complementarities that exist, right? So this says the time to adopt cover cropping was 70% lower for producers that had already adopted continuous no-till. So if you're doing continuous no-till, it might be much easier to work cover crops in or add them to your operation rather than somebody who has never done, maybe they've always used conventional tillage. They may have different reasons for that, but it might be a different amount of time consideration that's there. Also, people who are already using no-till tend to be more likely to adopt both cover crops and using manure as a fertilizer source. Might be worth investigating that a little bit further, depending on whether or not manure or inorganic sources of fertilizer are being used on a particular operations. There could be many physical reasons, right? Whether or not they even own a piece of equipment, a no-till drill that's needed. What's going on in terms of pre-plant requirements? Do they need to burn down cover crop and seasonal labor constraints? Frame the decision as whether to adopt a system of practices that work together rather than treating these things as a system of independent practice decisions. It may sound like common sense, but it certainly seem to see different rates of adoption and success when people have more than one practice in place and they're taking all these things into account. Very quickly, some new evidence that I don't think is really out there tries to look at when we look at tillage and when we look at cover crop adoption on farms. Here we look at soybeans and we look at corn in the two most recent years that we had data for when we initially did this study. The tillage cost story that we talked about a minute ago holds. That is, we see lower total cost, lower fuel cost, and lower labor cost, accompanied by a higher chemical cost. All right, exactly what the literature suggests would be the case. We see that in the data. That's not probably a surprise to anybody. Maybe most important or most interesting, at least to me, is that we don't see any detectable yield difference for either of these practices for either of the crops, that is for conservation tillage adoption or for cover crops in all of our corn and soybean data for the 2 years that are here. So we're comparing fields that do and don't adopt. And this is really the most common concern that you hear expressed when you talk to people who haven't adopted either one of these practices or worries about yield. We don't see it, at least in the data that we have available to us. One killer caveat here is that this is very early in the data for cover crops, and we don't have a massive amount of cover crop data. So we're looking at the most recent 2 years to try and see if this continues to hold, as our adoption rates have gone up quite a bit. In terms of yield, there may actually be a positive effect. There is a slight positive estimated effect on yield for cover crops. And then we have those lower cost findings that I just mentioned a moment ago. This is arguably the most defensible and widely applicable finding in the entire report. That is that we don't see in our rich data, we don't see major impacts on crop yield, and potentially even positive ones in certain places, which is consistent with some of the most recent literature. And our production costs are consistently lower. This is for conservation tillage. We're not able to do this yet with this detailed analysis you're seeing right now for soybeans, given lower adoption rates. I'm going to try to wrap up here in these last couple of slides. In terms of conservation tillage, trying to think about management planning and decisions, checklists, the cost reduction I just mentioned is the most important thing to sort of think about. If you can reduce or eliminate tillage in your system, you do have to make sure that you consider the increased cost of using chemicals if you're not going to be using mechanical weed control anymore. Fuel and labor savings are significant, but this is an important consideration, especially if you have any persistent or herbicide-resistant weed issues that you're trying to deal with. As I mentioned before, expect a transition. A long-term study found it took about 13 years to recoup all of the initial expenses when you think about the equipment costs of like a no-till drill or something like that. Shifting over to cover crops, 4 key things. Are livestock present? We talked about that. There's a value to that biomass that you can immediately capitalize upon if you have animals, or maybe a neighbor has animals that could graze and potentially provide a lease payment or something for grazing that. Is there cost share, and how many years of that cost share might you be able to take advantage of? Are you addressing that in-field research concern? And is there a no-till drill or pre-plant burn down paths that are already present in the system? Those are all things that are going to really help improve the economics on cover crops. In terms of lease negotiation or landowner conversations, the time horizon is important when we think about whether you're a landowner or you're leasing out most or all of the land that you're there. By construction, interest rate or rather discount rates that people use are going to be very different depending on whether they're owning or leasing, and that could be enough to really shift the equation one way or the other. I didn't focus on it here today, but we do talk more specifically about interest rates and thinking about the long run net present value of transitioning your tillage system away. Land tenure is an important covariate. We do control for land tenure in those last results I was showing about comparing yield and cost differences. And there is an entire report actually from about a year ago that looks specifically at this issue of adoption on owned versus rented land. If that's something you're interested in, I could certainly point you toward that from my colleagues, Schmerlo and Burnett. complexity is always going to suppress adoption, right? If you've got a lease that requires an operator to make many interrelated decisions, or that involves many different people that need to approve and sign off on that, that might be a harder thing to just to operationalize, and we might expect lower sort of compliance. So setting conservation as a default in a lease or something like that might be one way to get those things inserted if you've got a landlord or a landowner you're working with who wants to use these practices on their land, wants their tenants to do that. That might be a way to sort of work it in. There's a number of different things in terms of that might be relevant for appraisal. I want to say that I don't talk about land value anywhere really here. We're not able to say too much about it from the data that we have. This is a really important and interesting question. One I've talked to groups about in the past. Others may have ideas. I'd be certainly welcome to talk a little bit more about valuation and appraisal sort of issues and how they're relevant here. There's a number of gaps in the study. I'm not going to focus on these. I'm going to, in the interest of wrapping up, just pull here to the end. I'll leave this slide up and just stop here so we've got some time to take questions and I can interact with the audience or address any questions that may have come up over the course of the talk. So I don't use all the time myself.
Hey, Ben, did you see that note just came in from Nick with a question? Would you like me to read that for you?
I just pulled it up. Let's see here, Nick. Cover crop could stand a better chance in the Midwest if it's a cash crop that can be snuck in between corn and soybeans. Yes. So yeah, talking about pennycress as an example. This is certainly something that is getting a lot of attention, whether it's through the sort of the biofuels channel and sustainable aviation fuels. There are some other perennial grains and other kind of things that are being tried. I certainly think anytime you can create a cash flow, a revenue, not just an expense, at least on a financial basis from that cover crop, then that's going to be beneficial. That's like the story about being able to use it as a forage or a feed source. That would be very similar here if you can get a cash crop out of it. Obviously, that's why winter wheat is a thing that people are interested in. That's effectively, agronomically a cover crop. The one key thing to think about in light of what I said is that at least for NRCS programs, you can't currently receive payments for the cover crop as under their practice 340, I think is the practice standard. You can't currently receive it if you're generating revenue from the crop. So they don't treat those things as cover crops, even though they clearly are functioning that way on operations. Any other cash crops on the horizon that I'm aware of? I can't think of anything right off the bat. Certainly, I've heard the pennycress or covercress idea, so I think that is intriguing, and it'll be interesting to watch. And maybe some of these new incentives around sustainable aviation fuels and other regenerative incentives might be able to help improve the economics on some of these things as well. Thanks, Nick. I see. Ellen or Elin, let's see what's this say. Can you explain more about how tillage being cost savings relates to soil health? Okay. I mean, the general argument for reducing or eliminating tillage in terms of soil health, not an agronomist, I'm an economist, so I didn't try to emphasize or make that particular case. The general argument on the soil health side is that with less soil disturbance, we get all the organisms and everything else that are present in the soil are certainly potentially more vigorous, earthworms and all these kinds of things. But what you get are improved infiltration, better bulk density, lots of these different metrics that we use to quantify more healthy soils in terms of all these different attributes. They can be considerably improved by reducing or eliminating tillage. There's always a trade-off with trying to think about compaction and other types of concerns. If you stop breaking up that soil mechanically, which is one reason why, different types of cover crops are used with rooting systems to try and do some of the tillage that's not necessarily happening. How does this work over the short versus the long term? Do benefits increase over time? So I think that people who are long-term adopters of no-till or reduced minimum tillage systems would argue that the economics improve over time, mostly because they're able to take advantage of time savings and other things, the huge reduction in labor, not just machinery costs. So I think people do see better benefits over the long term. It certainly depends on where you are, north to south, and whether you have shorter growing seasons, whether or not the economics may look more or less favorable. Hopefully that addressed that. Let's see. Ethan has a question in here. I'll just move to that one. Any indication of changes in Northern Crescent and Heartland areas being driven by changes in state regulations? This is a very interesting question, and you mentioned Minnesota in particular. We have not dug deeply into sort of within states and other things to see if we see individual states sort of standing out. I would say I'd be surprised if the recent changes in Minnesota are showing up in the statistics that I showed with the map and the Northern Crescent. It will be interesting, I think, to watch the next couple rounds of data come in to see if we do see any kind of a change, and it looks to be systematically different in a place like Minnesota that is putting a lot of state dollars into incentivizing these practices. So it's a very intriguing question. We do see differences. Maryland always stands out as a state. Looking back, where you've got much higher adoption rates than other places, and that can certainly be explained by some of their practices. What else we see? The buffer law and drainage. Yeah, drainage is an interesting one, especially since you mentioned Minnesota. We actually have shown in some recent data that there's actually a pretty significant increase. Some of the counties with the highest increase in drained areas are actually in that sort of southwest corner of Minnesota, basically sort of where the Corn Belt is maybe arguably expanding as we get some more mild winters and shorter winters and that kind of thing. Elin or Ellen, you're very welcome. I hope I addressed your question there, Ethan. I'm happy to answer anything else, but we're probably at the end of our hour. I don't know. I can hang on if that's copacetic.
I would love to be able to ask more questions if I can. I don't have time to write them. I mean,
Great.
yeah, I thought that no-till question was very interesting because I used to work on a military base, and we were right next door to a lot of farmland right outside the fence. But we shared a creek and drainage area. The farmer, somehow the creek cut very deeply into these soft soils that were right next to the Missouri River. And anyway, so he or she tilled to the edge, and so that was often caving. So if he'd left the buffer, he wouldn't have had that constant shelving, whether small or large chunks, going into and causing some sedimentation in the water, which is, draining into Missouri, which then has other spin-off effects. So I wonder if that may be some part of the reason in Minnesota that was mentioned there.
Yeah. So Minnesota has put in place some setback and buffer requirements around all of their streams and rivers to try to get the general benefits, of course, that can come from having that buffered vegetated area around them, intercepting nutrients, soil, protecting stream banks, all of those things, right, happen with that. And not plowing up to, if that's the situation, up to the edge of the stream, of course, is one way to reduce that. That just creates a buffer there that does that. Obviously, you've got biodiversity and other kind of benefits from it. I think lots of people probably have similar story to the one you just described, or have observed this kind of thing, whether it's a neighbor or a place they drive past regularly. I have many times driven by, and when you see a fence at the edge of one property to the next, there's sometimes a drop off in the
Mm-hmm.
soil level, right?
Oh,
And it's just
wow.
very clearly shows, differences in practices that have been put in place, or it's a grazed field versus one that's being more
Yeah,
intensive cultivated. So you certainly see those things on the landscape. Um, and they're, the reasons that we initially sort of started to practice these practices alongside energy conservation and trying to save costs back in the petroleum crisis
right.
in the 70s.
Well, I just want to quickly mention the reason I'm interested in your talk, even though I'm from BLM and not don't have clients as farmers, is because we have large areas that are often undergo project work. And so solar farms go in on public land. And when they put in a solar array, sometimes there are over 4,000 acres, and so they go in with front loaders. And so what we want is not just have a bunch of weeds come in and not ever really have a restoration of the native habitat that was there in between the solar panels. So your work on the no tillage is really informative in that respect for me. So there is a lot of similar activity going on in there. So just want to tell you how your results relate. But I do have one other question. I have in-laws that used tilling. They had several large fields, but they also used plastic over the areas where they're going to plant. And I think this to prevent weed growth. And I wonder, how does that affect the soil in the long run?
I am not the right person to ask that question to.
Hmm.
Certainly, I would suggest. I mean, you see black plastic and things like that
Yeah.
being used when you've got raised beds or
Hmm.
other sorts of things. Vegetable production in particular is a place I usually tend to see that. Um, it serves a number of different purposes, but I'm not sure if there's any known important specific considerations to think about as it relates to tillage or other practices,
Hmm.
or how it might fit into a system of soil health practices for a particular operation.
Hmm.
Might be able to track down somebody else to be able to give you a better answer for that. But it is an
Okay.
interesting question.
Yeah, thank you.
Yeah, let me switch gears here. Looks like there's a couple more questions in the comments. Jingyi says, "How does joint adoption of no-till and cover crops um, or other practices get paid for under the programs that we talked about as compared to sort of individual practice adoption?" So, um, the EQIP and the CSP program were the two main programs that I mentioned from the USDA. Both of those programs will pay for more than one practice, and oftentimes um, the way that those conservation plans are put together and then implemented, and contracts and everything else through those programs is actually a system of practices. It may not necessarily be no-till and cover crops, although those two things do get used together very much on the same contract. So maybe you transition into no-till in years 1 and 2, and then in year 2 and 3, or 3 and 4, you add cover crops into that no-till system. That would be an example of how a 3 or 4 year contract could potentially be structured. But usually there is a combination of practices. So it might combine nutrient management together with no-till or together with cover crops. And so payments are set up and phased in over time with the practices in order to address the resource concerns on the field. So those programs do pay for more than one practice. The key difference, one key difference between CSP and EQIP, if you're not familiar with the programs, is that CSP, the Conservation Stewardship Program, is designed to recognize past and continuing conservation activities and expand or enhance the conservation that's going on. So take practices that have already demonstrated to be successful as an operation and add them to additional acres, or add new practices that weren't present previously onto those acres. So that's one way that works. Equip, however, is for new adoption only. New acres where you haven't adopted a practice before, or practices that you've never adopted before, are the way those will work. I skipped over Windong's question. How valuable are state level payments relative to federal payments? So I don't know how big the payments are in the new Minnesota program. Someone had mentioned new programs coming through Minnesota, so I haven't scrutinized those in particular. But the $5 per acre programs in Iowa, Illinois, and Indiana that I'm aware of that sort of mimicked or went along with in the same way that the pandemic cover crop program were set up are relatively small, and those work are operationalized as a discount on your crop insurance subsidy rather than a cash payment. But if you look at a state like Maryland, Maryland was paid quite a bit. They're much higher than the average payment for cover crops when they were initially implementing their state level program. So it just depends, I think, where you are and exactly what they're trying to target. The impetus there was around Chesapeake Bay protection and watershed protection in the broader Chesapeake Bay and the efforts that were going on in the state of Maryland. I believe they also have an afforestation program in Maryland that I'm not as familiar with. Hopefully that answers your question, Wendong. Looking at this other comment from Ethan. Am I familiar with Sentinel Landscapes? I am not personally. Oh, he's asking Eland, connecting there. There aren't any Missouri, but okay, cool. All right, good. Interactions and sharing information between the attendees. Great. I guess I think I addressed everything in terms of questions that have come in. And I guess we're at time. So maybe we've reached the end of our time together today.
Thank you so much, Ben. We will record this, or it has been recorded, and appreciate you all being here. It'll be in the membership of ASF MRA, so let us know if you need access to anything. Thank you.
Thank you all.
Thank you,
It's been
Ben.
great. Appreciate it.
Yeah, thank you for this presentation. It's wonderful.
Thanks for your questions.
Mhm.